we are talking about our solar battery, right? I've just given you the definition of what solar battery. So in the next 10, 20 to 30 minutes, I will be running through the battery, principle of operation, the types of battery that we have, and any other things, the ratings. Battery also have ratings. Hello, principle of operation, the types, we talk about the ratings. Then we go to how to connect this battery, maybe in series, parallel, or series parallel, right? So I said that in the battery process, it works in an electrochemical world process. Hello? Hereby, when you have your panel, this is your panel, right? Assuming this is your panel, let's use two panels connected together. Then this is our what? This is our charge controller. Then this is our what? This is our battery. This plus, and this is what? Hello? So let's just say this battery is 12 volts, 100 amps hour. Hello? Now, remember, this is also a block diagram of the entire solar system. Now, remember that this battery will also be connected to what? An inverter system. Let's use this block as what? Our inverter. So part of the inverter, there will be a cable that will be running from the inverter down to what? Our battery. So the first process happens from electrical down to what? Chemical. The battery is a chemical device that's stored. So when you expose your solar panel, when you put it on the sun, on the roof, it attracts the power, right? It converts it and it gives you DC power. Then it comes through controller, it comes to your battery. As it's coming, I explained this operation yesterday, that the charge controller will regulate it and see your battery level, both voltage and current. So the more it's feeding your battery and it's storing there, the more also charge controller is seeing the level of which the battery is coming up and it's reducing its charging rate per seconds per minute. If the battery was 11.8 volts, as the panel comes, there is some charging the battery to the able to the controller will see that this battery has hit 12 volts. If I was charging, if it was going in with maybe 5 amps, since I've charged to 12 volts, reduced to 3 amps. If I go again from 12 volts to 12.5 or 6, these 3 amps will now reduce to 2 amps until it becomes 13.5 volts. That means the battery is totally filled up. It can be still be dropping on it and allow the battery to float to 14 volts at float charge. But immediately you come here and switch on your inverter, the battery will come back. That means you have put it to use. The battery will come back to its state of charge. That means to its usable energy. I draw something like this yesterday, that at the bottom we have 0%, right? Then at the top we have 100 what? %. At this place we have what? 50%. So if this battery should climb, it is not climbing from what? From 0% to 100%. Now let me explain something. There is something we call state of charge. What did I say? There is something we call depth of discharge. What did I say? This one is SOC, this one is DOD. Every battery operates in these two forms. There's another thing that we call usable energy from the battery. Usable energy from the battery is the energy that is allowed for you to be used. Is allowed for you to use at that particular time. Now let me explain these two words: state of charge and DOD. Now, state of charge, this is my battery. I have the battery running from 0%. Hello. Ideally, DOD is 50%. DOD of we have about, for now, let's classify the battery as 2 types. We have the one we call the gel battery. Okay, we have the one we call the lead acid batteries. Are you getting me? We have the one we call the lithium battery. Battery are classified in many categories, but let's just talk about these two. Under these two, we have the lead acid, we have the lithium battery. Hello, how many of us have seen lead acid battery? Lead acid battery. You have not seen lead acid battery. Under lead acid battery, we have the dry cell, we have the wet cell. All those batteries are classified under lead acid battery because there is an acid in those batteries. Hello. Okay. For those that have not seen before, have you seen something like this before? Okay, now you have seen. Okay, have you seen? So I know that many of you have seen it, right? But you might not know. So this is classified under lead acid battery, and this one is sealed dry cell. So the wet cell is those what they call tubular battery. So who have seen a battery like this that have 1, 2, 3, 4, 5, 6 on top? Eh? You have seen it. I know some of you have it in your house. Tubular battery. Tubular battery. That is the popular name. So this one is wet cell or flooded lead acid batteries. Hello. So this is you are seeing what is an indicator. If you are come close to it, you see that there is one thing like an indicator pointing here in this on this pointer up there. Those things you are seeing here, they put it there for you to know the level of the acid in the battery. Hello. And battery majorly under this category are rated in 12 volts. Who can tell me how we come about having 12 volts? Anybody? When we say this battery are rated in 12 volts, you will see something like 1, 2, 3, 4, 5. Okay, let's count how many buses we have here. Let's count. 3, 4, 5, 6. So today you will not know how come about that they say this battery is 12 volt, 12 volt. Hello. Even from the lithium battery, there's a way they stack up those lithium batteries to become 25 volt, 48 volt, 24 volt, and all of that. So when you see a device or necessary component, you begin to attest to, okay, this is how they can come across it. When I was talking about the solar panel the other day, I said that each of these cells is what? 0.5 volt. At least I'm giving you the breakdown of which you can know how to come about the rated capacity in different categories. So if you don't get it in this one, maybe you can get it from this other side. Maybe somebody want to tell you what is not relating, or you understand? You can ask, okay, if I need get it from here, if I get it from here, I've also arrived. So that you don't just rely on what somebody will tell you. You have to know it for yourself so that people will not deceive you. Are we together? So now, the reason why they rated it, if our panel can have 0.5 volt per cell, that means our battery can also have, because this one you are seeing is a cell. This one is a what? Is a cell. The cell, the cell, the cell, the cell, and this one is a cell. So we have about 6 cells. On this battery, we have 6 what? 6 cells. And each cell is 2 volts. Hello? Is it interesting? So when you now multiply 2 times 6, you have what? 12 volts. Hello? So the indicators here on this different cell will now tell you that, okay, if this indicator here, the pointer inside this indicator, because they are usually the indicator that will be on the glass is not exposed unless the glass is broken. So maybe when this one drop down to this level, and this one drop down to this level, you will now see that you will need to refill that battery. It depends on the condition that will determine what we use. We normally use distilled water. There's a condition that the battery will drop down to, right? You will now use electrolyte, or you drain off the entire acid. You now top up electrolyte. Electrolyte is more dangerous. It's more harsh. It's more of acid than distilled water. And when you handle it, you don't handle it with what did I say? You are serious, you'll be serious about it. You put on your gloves. If possible, you put on goggle. You wear glass. Because any drop, there was a case of incident that somebody sent his boy to go and top acid on the battery. I mean, something happened. He said they drop. I don't know how it happened. Splash on the boy's eye, and that eye went blind. So that is why you have to be very, very, in any system you are working on, you need maximum carefulness. I told you the other day, one of the risks that you have to mitigate or minimize on the roof is that always pay attention. Some persons where they are doing anything before you know their mind has left that thing. They are easily distracted. Hello. So you cannot climb on the roof and now be pressing for, be shouting. Say no. Because any slight mistake, you might just before you know. And it's not something that you wish for yourself, because most times falling doesn't really end with just just go and massage, go and treat. You might end up break something, or if village people follow you, maybe you might not live to tell the story the next day. So whenever you are at work, always give all it takes. When you close, you can go back to what we are doing. Hello. So I was talking about the battery system. So the same thing that happens whenever you are opportune to work with the acid or electrolyte or this system, even if it's normal distilled water, you can still practice safety. Because what you have not been practicing, even the day you will hold raw acid, you say it's normal thing, it's common, so it will not happen, nothing will happen. It's only God that has been protecting us. But that does not stop the place of you playing your part, not playing your part. Hello, are we together? So this is how 12 volts comes in. Many people did not know this 12 volts. Even some of the installers, they don't know this 12 volts, because most installers are electricians. They just dive into solar. Some of them, they don't even learn the work well, or even learn it. They just they think solar is just wire now plus minus. That's what they will say. Solar now plus and minus. That is what they will say. Because it's still related to electrical connection and all that. And there are more. If we go into the part of connection now, you will now know that not be to hang panel. Because the ability for you to do a satisfied job is for you to deliver. If along the line you can encounter issues on the site, you have to deliver. Who you want to deliver for, you go wrong. And maybe you are a client that say, let me pay you 70%. When you are done, I will balance you 30%. So wait, you go leave your money for them. Maybe that 30% is your workmanship. We have to deliver. So it is more than just hanging panels. Hello. So I was talking about, this is example of a lithium battery. So I was talking about this SOC and what? DOD. And I said SOC is what? Then DOD is depth of discharge. So let's come back to our analysis. Hello. So ideally, under normal design, tubular battery or lead acid battery should be discharged at 50%. Should be discharged at what? 50%. That is what is recommended. So in other words, 50% is the usable energy that is needed what? From you. Now when you reach 50%, you do what? The system should cut off. Hello. So when you are designing, you put at the back of your mind that, oh, this whole battery, like this battery is 12 volt, 40 amps. Are we there? This battery is what? 12 volt, 40 amps. As you are seeing it, this 40 amps, the usable capacity I should be expecting from this 40 amp is what? 20 amps. So even as big as you see it, it is now, is not everything that I'm able to drain. Right? And another thing is their life cycles are different. Other lead acid battery, they tend to last for 2 to 4 years. Under normal maintenance, they can be extended to, if you are maintaining it very well, and if you obey the installer or engineer instruction, you can extend it to 3 to what? 5 years. By this time frame, this lead acid battery should do what? To pack up. Then you go and replace it with a new one. Hello. Then lithium battery can last for 7 years to 10 or to 15 years, depending. Hello. So maybe I might come across a video that says everybody just talking about lithium battery. To the extent somebody will not saying that if you have job or tubular battery, it will not do. You're not happy, lithium battery. Tubular battery is still working till now. Hello. And most of them are stronger. But we have different brands, we have different products in the market. Everybody just want to sell his market. You understand? We have good tubular battery that are still running well. Till today, people are installing tubular battery. And it's still budget friendly. So when you are thinking about this thing, think about the cost. Hello. So tubular battery, lead acid battery are heavier and at the same time they are cheaper. Lithium battery on the other way around, lighter, they don't consume more space, unlike lead acid battery, but they are costly. But they last longer than tubular battery. Even in years, even the depth of discharge. This is, if I'm talking about, okay, this is lead acid battery. Then if we talk about this one now, this lithium, this is 0%, right? This is 100%. Are you seeing it? Okay, this 0%, this is 100%. So if we do it now, okay, let's start from 0% to 100. Tubular battery tends to drain 50. Lithium battery, we do what? We come down to 75% to 95% DOD. Lithium battery, they drain more deeper. They give you that flexibility. They give you that more time than what? Lead acid battery. They can drain up to 80%, 85, 90. Some brand you can even give up to 95%. But when you are designing, you can't design with 95%. You design with 80, 85. So that you'll be on the safer side. So I'll talk about how we come about 12 volts. Is that not so? Then this is tubular battery. This is what? Lithium battery. And I've said that lead acid battery, they drain at the usable energy is 50%, right? Which is 50% DOD. So it's expected that when you use 50%, the battery will be cut off. Lithium battery, you can use the battery down to 75, 80, 85, even 90%, then charge again. Before the question, let me talk about the state of charge. Now, hello, everybody look up. Let's do some mathematics. Now, in the state of charge, this is 0% to 100%. Are we good? Let's use tubular battery, lead acid battery, for as a case study. So if we are to connect this, if we are to use a battery of 12 volts, 200 amps hour. I'm talking about SOC, state of charge. If I've used this battery to 50% from 100, hello, are we getting it? From 100, I've come down to 50. You know, I'm using it now. No, this situation is basically the night where there is no. So let's put the battery to reuse capacity and usable energy. So you are starting from the up from 100%. You are now consuming. Maybe you on fan, you on your TV in the night. You come back from work, you will relax. You plug your laptop, you plug your phone. Just want to see a movie and go ahead to do other things. Maybe on one battery system. So you are not using it from 100%. It will be coming down to 90, 80, right, 70, and then when you come here, it will be what? 50%. In other words, you might not be seeing this exact percentage I'm talking about. What you'll be seeing, it will be dropping on the voltage level. So if your inverter can give you that reading, basically it will be on voltage. If you want the inverter at 12.5 volts, after maybe 20 or 30 minutes, it will not drop to 12.4. After 1 hour, it will not drop to 12.2. After maybe 2 hours, it will not drop to 12.1, 12.0, until the battery will get to 11.5 volts. Then the inverter will begin to do ping, ping, ping. That is low battery load. It will either tell you shut down or reduce load. The inverter itself will be telling you, because the battery has reached its cutoff place. So the energy is no longer sufficient to keep on powering those loads. So battery can be designed to cut off at 11.7. Every company with their own design. Hello, everybody. If you come up today that you want to do a solar system, maybe from panel battery, if other people have been designing their battery to last or to cut off at 11.2, you will not say, no, this thing is not good. It might be because of market strategy to sell more. But you will know that for this, my system to last longer, I need to do my own design, let my own be cutting off at 11.8 volts. Then we now produce the battery and make it like that, so the battery will not overdrain. Second thing that will help you is that the inverter will also help you. Most times we will set it that cutoff voltage should be 11.6 volts cutoff. So that if the battery does not have that friction of cutting off and not allow the battery to drain down to 0%, because the more you drain the battery down to 0%, the more the battery dies faster. The more the lifespan do what reduce. So in other words, if the battery does not have that features for you to regulate it and cut off at the percentage you want it, you can set that system, do that setting from the inverter. And the inverter will help you to be cutting off the battery on time. Hello? Are we getting it? So now before the question, if this thing lasts for 50%, how many do you have here left? Hello? If we use the battery to 50%, what is the range we have here? We have what? 50%. So if these are what 50%, right? 50%. So this remaining 50% is our what? State of charge. What did I say? These are 50% is our SOC. Because when you want to charge this battery, the battery will start to fill up from that 50% going off. It will not come and start from 0 point. It will start from that 50%. So the DOD is your depth of discharge, and 50% of lead acid battery. I say this battery 50% is what I give out as usable energy. State of charge. Now, if you now drain that battery to be 60%, then your state of charge will be how many percent? Your state of charge will be now 40%. That means the battery will start to charge as at 40%, going up back to 100%.